and this talk was intended to be co-presented with Mohammed Rafi. He did the implementation for the recent changes that we have made for RDMA support in Gluster. So I work for that, and I work in the team which takes care of integrating SMB with Gluster. And just like most of us here, I dream of being able to visualize Gluster code like Neo visualizes universe code, just like this. Still not there, but yeah, right. Yeah. Agenda for today, we will be talking about what recent changes we did in Gluster for RDMA, how to use it, what are the features, what are the implementations, bit of admin side of stuff. Then we will go on to the other side where we will talk about what difficulties we faced, or how code maintenance became a problem, or what measures we can take to make it better moving onwards. Some future enhancements that we have planned, either in near future or somewhere down the line, and a few ideas which may not be complete yet, how to extend to be better able to make use of the Gluster resources we already have. Gluster is very well thought out library which we can make use of even beyond the Accelerator stuff, maybe allowing applications to make use of Gluster. So those are the ideas. When we say RDMA support in Gluster, currently we mean that the RDMA protocol can be used as a means of communication between the client process and the brick process. Clients include Fuse client, all API clients, so NFS and Samba included. Also the GNFS server, and node services like Selfie, Daemon, Potadi, and Rebalance. The other side of this is that we still do not have support for RDMA when we are asking for communication between NFS kernel client and the NFS server we have, or the SMB client and the SMB server we have, which is Samba.
One correction, we don't have support in the sense we have not tested it. Whatever protocol the NFS client uses with the server, that RTC or RDMA, the entire RDMA is written in compliance with the RTC or RDMA RFC. So the thing is, we couldn't devote enough test cycles.
Also, we would need the NFS server or SMB server to support it, which I know that Samba still does not, and we are still.
Yeah. So definitely, if you go to the code fix, we will spend lots of bug fixing and other things. But I don't think it's fundamental changes required in the current RDMA.
Not in our implementation.
Yeah.
Yes. So a few slides on how to use setup RDMA volumes and stuff like that. So to create a trusted storage pool, one of the requirements that we have is that if you are using a InfiniBand device, IP device, then you should use the same IP that you have assigned to IP device to do the peer flow. And all the nodes that we have in our trusted storage pool should necessarily have the IP device or any RDMA device. This requirement comes because of few reasons. Most important being that the study needs to listen on both RDMA port and the TCP port, and if you are running the study on a node, it is probably part of the trusted storage pool. Similarly, for the GNFS server that we have, it could also serve clients, and it would also need to communicate with bricks over both the protocols. So we would want all the node servers to be having the RFP device. So what changes when you introduce RDMA? Gluster D starts listening on two ports now. The well-known 24007 port is what it would use or continue to use for TCP, and it will start using 24008 for RDMA communication. Also, for the brick processors, as we all know, it will by default start with 49152, and every brick process will listen on two ports, one for TCP and one for RDMA. So anybody who is configuring their servers, they need to make the changes in firewall to make sure that communications go through. Creation of a volume is same as non-negation. You just need to specify the transport type that you want the volume to support. By default, if we do not give any of it, it is taken to be TCP, and you can choose to have an RDMA only volume, or you can choose to have a TCP RDMA only. It is necessary that you have the RDMA device. As I mentioned, because the node server will have, we will not do any checking here, informing you of not having the IP device or RDMA device on clients. We will go ahead and create the volume because the server would already have it, and later nodes may fail if you don't have IP devices on the client. To support the transport option on the mount side, we have another transport option on mount. So you can specify what transport you would want to use. Okay. So in case of TCP and TCP RDMA volume, when we support both, if mount command does not specify a transport type, it will be TCP. And in case of RDMA, it is automatically taken to be RDMA. So this is the command, for the last line, but basically you need to specify which transport you want to use. And as required, here you cannot specify TCP, RDMA, you have to choose between either TCP or RDMA when you are doing a mount. This is for admins who want to convert their already existing volumes into RDMA volumes. We know a few community users who have IP devices with them, 40G IP devices, and they are currently using it in IP over IP mode using TCP. So if you would want to make use of RDMA support, this is the procedure for that. Just unmount the volume on all the clients, stop the volume, change the transport type by volume set, and then you are ready to use it in RDMA.
Where do you start the volume?
Okay, the reason is that when you do this volume set, it does not get automatically reflected on the brick wall file. You need to restart the brick processes.
Okay.
But instead of saying restart the brick processes, we have just made sure that they stop the volume and restart it.
Okay.
The networks don't get automatically reconfigured is the problem.
Okay. Don't seem to be starting.
So, what transport would be used by node services? Again, self-redeem and rebalance and other processes. Here, they have been written in such a way that they always go with the default. And as I said, if you have a TCP RDMA volume, you will go with the TCP default. We still do not have configuration options. For example, if I have a TCP RDMA volume, but I want all my rebalance traffic to go over RDMA because that makes sense. We do not have that, so this is one of the feature enhancements that we are looking at. So, recent changes and performance improvements. So, the main idea here is that we had RDMA support from a long time in Gluster. Raghavendra had done the implementation of RDMA protocol itself. What changes have happened in 3.6.2, 3.6.3 and 3.7 is mainly bug fixes and one important performance improvement which has given us good connectivity. So these are a collection of those. To give an idea, there are totally 19 or 20 patches which have gone in to fix RDMA in various places. But the ones which I have highlighted in red are the core RDMA protocol bugs. So only 3 out of 20 were core RDMA protocol bugs, and the rest of it were either related to cluster D or how a new feature did not think of how did it interact with RDMA and stuff like that. We need not go through the list of patches. This is the interesting stuff. So Ravi, when he was working on this and when he was getting numbers to measure the change in performance after all the work was done, he realized that we were not performing well with writes. So before the enhancement was done, but after all bug fixes were done in RDMA, we saw that write would be around 346 MB per second, and this was on a 10 gig IP device with replica 2. So ideally we should have got 1.2 GB per second as the complete speed, and because it is replica, it would be 1.2 GB per second. In the line speed, yeah, because it is replica 2, it would be half of it. So somewhere, just a minute.
600 Mbps.
10.
600 Mbps or 550 is what you would expect with replica for writes, right?
So 10 gig would be around 2.5 GB per second.
No, 1.2.
Yeah, 1.2, and then replica 2 would be
Half of that.
yes. So we would be 600 MB or 650 is what.
Where it says replica 2 old ConnectX 2 series 10 gigabit, the old ConnectX 2 series were 20 gigabit, not 10.
The one we had in our labs were 10. They should be 10, 20, and 40.
Must have been some weird model. Okay, cool.
Yeah.
Cool.
Light source of this.
Yeah.
Could be.
The card we have in the machines are FDR.
Oh, that's the new one. So they're talking about the old ConnectX new one. Like the one that was just in. Sorry.
No problem. So yeah, as we calculated, the max that we should be getting is 600 MB per second, but we were very close to the 50% of it. So when Rafi was researching about it, there is a blog called RDMA Mundo, and it is maintained by one of the Mellanox guys. His name is Dayton Tarak, I think. So he suggested Rafi of possible places where we may be having latencies, and the reason here is that we do memory registration for RDMA during the IO call. So the buffer comes in all the way till our transport, and then we talk to the kernel and we say we want to bring this memory with this IP device, and it is a high latency operation. So his suggestion was to not do memory registration during IO path and do it beforehand. After, so there are two ways we could have done the registration beforehand: have a separate pool for our data path and have it always registered with IO. But there were problems with making it work with our IO cache translator, which uses the same pool. And the other option was to raise the whole of IO of pool which we have with RDMA and let IO cache use it as is. So after the changes, we have got around 425 MB per second as the total speed, and this is not yet there, but close to 70-75% of the line speed that we have. In some of the tests, we have reached 90%, but because there is variation in data, this is the trusted for sure. We need to explore more on how to make it 90% throughout. With some help from Mellanox guys, I think getting 90% should not be a problem.
We have newer InfiniBand stuff inside the Red Hat network. You're using that now, or?
Rafi has access to it. He hasn't started working on it. He's busy with
Yeah.
Okay. So these are the performance patches that we have. What we spoke about is the first one, and the other three are minor enhancements which have given some amount of better performance. So okay, what we learned during this RDMA changes, this is the point. Because RDMA requires special hardware, we do not have any regression tests in the upstream direct, and tracking regressions in such a case becomes very, very difficult. You don't know when a new feature can cause problems in RDMA, because unless you try it out on a machine which supports it, we cannot do anything about it. And for lack of better wording, I have mentioned that RDMA is an alternative to TCP. What I mean here is that,
Just a question. I know it would be a lot of effort, but there's a pure user space thing. It's IOR level implementations that doesn't require hardware. So would there be an option for it, right?
yes, there's an option. Our next slide.
Sorry.
Yeah, that's all. So, RDMA is an alternative to TCP. Why do I say this? So, whenever a system gives you options, and one of the option is very well respected and more widely used than the other usually gets neglected. And that is what happened with RDMA here. We saw in the previous slides that out of 20 patches, we had only 3 which were fixing core RDMA protocol bugs, and the rest of it were bugs which got introduced later because people did not care about it. So I still don't have the answers on how to fix this, but I have been thinking on how to make some automated mechanism to rewrite our Gluster test. Yeah.
So what we can do is in the include.rc file, we can start making it optional. Is the volumes that are created if they're TCP versus RDMA, and so we can have a flag to the test, was it run test or whatever, to say this is an RDMA machine, and that would then set the flag inside include.rc and create the volumes throughout all the tests with RDMA. Something like that as a first approach.
Yes.
There would be bug fixes needed, but
Yes.
Yeah.
So but we still have to create a volume with transport type as RDMA to go with that.
Yeah. But what I mean is most of the volume creation is done inside
volume.rc.
Yeah. Not all the
It's not
time,
Yeah.
but yeah. So it's not a huge amount of places to do that.
You had a patch for that.
I
Right?
had a patch ages ago that then we hit problems and
Yeah.
didn't get onto it, so I lost it.
Yeah.
So,
I think we could also run nightlies for RDMA
yeah, that's
and
cool.
just report
Yeah.
back status. So that would be cool.
About the other point that you said that we could have a that we'll be talking about that in tomorrow's testing talk
Cool.
on how to move the volume creation and other stuff outside of the test to
Right.
make it more
Cool.
wide. Yes.
Okay.
More enhancements for RDMA. What we also observed during our testing was that our performance translators go with a default, which need not be right for RDMA use case. So we haven't pinned down on what performance translators need changes and what would be their defaults to work with it. But probably we can make cache less because RDMA works faster there. But right behind can wait a bit longer to collect more data because RDMA would be better used if you have larger data than smaller chunk size. And one of the main points for that is Fuse always sends data in 128K messages. So sending it at that byte size is not the best use case for RDMA. We need some correction mechanism. If we cannot get the change done in Fuse, it makes sense to do the change somewhere in our translators to make it better use of RDMA.
The best use case would be the Samba actually. Samba, since it uses RSMA implementation uses JF API. So bigger buffers with JF API, and I think it's 1 MB limits, right? The writes payload is 1 MB I think.
In SMB, yes.
In SMB. So with that, we can have the zero copy stack from 1 MB all the way from clients to the server. So the better use case would be JF API based application like NFS Ganesha.
The theory sounds good.
Yeah.
Yeah.
And that's the performance improvement you get almost no work at all because like it's very minimal. All we need to introduce is some GFAP interfaces
Right.
where which can take which can provide IO buffers to the application.
Right.
So since like our entire IO is based on IO, so the applications should be able to ask for an IO buffer of a particular size and then read data to that and pass along the IO buffer.
Yeah, you should
Very
do that.
minimal,
Yeah.
for very minimal work, the benefits we get will be huge.
Yeah, so
Yeah.
Davi already posted the proposal for that.
Oh, you did? But,
I think in February. I did not manage to reply to it. It's in my inbox to do it.
Yes.
okay, I don't remember seeing that. So.
Apart from that, InfiniBand optimizations, as I said, we have been getting help both from Linux guys and the talk that RDMA has. And we should be able to do better optimizations to work with InfiniBand. Coming to what Michael said, IWA and RDMA were converged Ethernet. These are the two other options that we have, and we should definitely extend support to that because when we say RDMA, it could be over these two also. So there is a community guy called Raghavendra, and he uses Gluster with IWA, and he has some set of patches which he has to make it work better. He had sent a mail about a month back saying he would be sending it over. He hasn't. I think Justin even followed it up for a while.
Yeah, that sounds familiar.
So, but we do know that it works. There are very few places where we have hard-coded it to work with InfiniBand, but if we make it generic there, it should work over IWA also. And as mentioned in the previous slide, we should definitely give out options to configure our node services to start using RDMA, because they will be all close together and we should make use. And coming to the point that you pointed out, what Rafi is exploring now, we should definitely provide access to IOBUF to applications to get to true zero copy. So even if we have complete RDMA support to get to the point where NFS clients and SMB clients start using RDMA in a true zero copy way, the data has to travel from NFS client to our server and from our server to the brick. We have the server to brick path. Once SMB and NFS come up with RDMA support, if we extend the IOBUF, it can use the same IOBUF and pass it down, and we will never be copying data from one buffer to other. We still have to decide on how do we want to extend or expose our lib cluster resources to something beyond cluster. We have never explored that yet. So one of the ideas that Rafi had was to extend GF API and not have it specific only for FOPS. Give out GLFS IOBUF new as the API, and it should be able to give you a part of IOBUF. Or GLFS dig new is other thing that we are exploring in users and stuff, to give out a dictionary for applications to fill out text data for us. So these are all thoughts at the moment, but it would definitely be good to get suggestions for the design before we start implementing. Another area to explore is that our memory management, we use page memory management for IOBUFs. These are static set of pages that we have of different sizes, and it would be good if we could scale it on the fly. That is one more thing that Rafi is currently exploring. These are the two main improvements that we are looking at from lib cluster side rather than the RDMA side.
So instead of creating different pools of different sizes, you would want a...
Probably still have pools, but those pools should not be in static numbers. For example, we have only 8 pools of 128K,
Right.
which get easily consumed and multiplied. It should automatically extend, like we extend our IO threads now.
Okay.
Something like that.
Okay.
That's all I have.
So you mentioned a bit about Rocky, right? RDMA or CE. So is there something that has actually happened with that, or is it an explored?
Actually, maybe just after the acquisition of some 2-3 years ago, I think we did have some tests for Rocky, but from what I remember, there were some bugs at the end, some crash at the end. But the catch is that whether those bugs were specifically related to Rocky, or we because of the general instability of RDMA, because if you look at the history of the RDMA, it was not supported officially for quite some time, and not done there. But there have been community members who have been using the implement, but Rocky, obviously, it's I don't think community members, how many members have tried that. But last I heard, there are some real bugs actually.
It could very well be that the bug was in some other place, because when we were testing RDMA, we have seen races which got exposed only because RDMA latencies are different than socket.
Exactly.
Right.
Exactly.
Yeah, that also could be a reason.
So it's the latency is exposed bugs in protocol client or RPC implementations, and that resulted in crashes.
Thanks.
Maybe they are putting their now. We just got it last week. So I think we should just take for servers or whatever and just set up a test file and use it for continuous integration.
It's a good idea.
Yeah. Sorry? No, you get this right? Yeah. That will be just an answer, right? Okay. I think we should have had a coffee dispenser here.
Want to discuss recheck?